Take a look at your CFU 1.6, where we're now going to take a look at specific measurements of center, mean, and median, and also take a look at how we calculate out outliers and how the mean and mean are affected by certain data points. So, first of all, let's take a look at question 1 here. It says, Cowboys. The 2009 roster of the Dallas Cowboys professional football team included 7 defensive linemen. Their weights in pounds are given here, 306, 305, 315, and so forth. So the first thing says calculate your mean, show your work, interpret the results in the context. So if we're calculating out the mean, all you're doing is simply adding these up. So I'm actually going to show my work. Thank goodness the data set is really small. But one of the things I suppose you could do is put all the data in list 1. Okay, and then just do one variable statistics. But we're just going to again show you how to do it by hand. So those are the 7 weights. Divide by 7 equals 305.86 pounds. So what does that actually mean in the context of the problem? So, well, mean is like the average. What's the average weight of all the linemen? So something to the extent of this. If the same number of pounds were spread equally among the 7 linemen, they would each weigh 305.86 pounds. All right, B says find the median by hand. So when you do median, okay, remember you're listing them in weights of smallest to largest and you're trying to find the middle. So you can see here I'm just listing them from smallest to largest, or by weight anyway. So I have 7 of them. So the middle is the median. So if I take here 306, it's right smack dab in the middle. I have 3 on the left and 3 on the right. So my median is 306 pounds. Okay. Well, what does that mean in a context? Well, that's in the middle. That means half of your linemen weigh more than 306 pounds and half your linemen weigh less than 306 pounds. So about half the linemen weigh less than 306 pounds, while the other half weigh more than 306 pounds. Remember, median is kind of like that balance points. I just noticed here this they didn't look good. All right, continuing on. C says, suppose the lightest lineman weighs 265 pounds instead of 285 pounds. How would this change affect the mean and the median? What property measure of center does it illustrate? So if I change this value to 265, it doesn't impact the median whatsoever. You'd still have the same order. 306 would be the median. Median doesn't change, okay? But since I decrease the overall weight of the 7 linemen, the mean is going to go down, okay? So I'm going to note that. The mean would go down in value while the median would not change. What property does this measure? Well, this tells you about which measurement is resistant to outliers. So the reason why this is happening is because the median is resistant to outliers. Means it doesn't change much, if anything, while the mean is not. The mean could change drastically. Here I believe it goes down by roughly 3 pounds. All right, continuing on, D says, find the interquartile range and interpret its value. So what I'm going to do is go back up here. Since I know that this is my median, what I can do is then look at these points and divide them in half, or find the median of the lower half and the upper half. Well, there's Q1, here's Q3. Now I can find my interquartile range. Again, interquartile range is equal to Q3 minus Q1. So in our case, that's going to be 315 minus 303, or 12 pounds. Okay, so what does that mean? Well, interquartile range represents the middle 50% of values, or whatever it represents. Okay, so we would say the middle 50% of the lineman weights have a range of 12 pounds. All right, E, last part of at least the first page here, says determine whether there are any outliers. Show your work. So again, with outliers, one of the things we want to do is, again, outliers are any value that is greater than Q3 plus 1.5 times the interquartile range, or less than Q1 minus 1.5 times the interquartile range. So one of the things I need to do over here is go 1.5 times the IQR. So in our case, 1.5 times 12 is 18 pounds. So now what I need to do is add that to Q3 and subtract that from Q1. So in our case, outliers, our Q3 value was 3, would be greater than 315 plus 18, or values that are greater than 333 pounds, or values that are less than 303 minus 18, which applies less than 285 pounds. Now, it's got to be less than or greater than those numbers. Notice how we had someone that weighed exactly 285 pounds. This is actually not an outlier because it's not less than. It's equal to it, but it has to technically be less than. So we would note we have no outliers. And I'm just going to note here, must be less than 285 pounds. So if it equals it, not an outlier. All right, let's turn to page 2. Right, got a couple more problems on the back here. Number 2 says house prices. The mean and median selling prices of existing single-family homes sold in November of 2009 were $216,400 and $172,600. Which of these numbers is the mean and which of these numbers is the median? How do you know? This sometimes can be tough for students because some of you might not be familiar with houses. But if you look at your neighborhood where you live, most houses look the same, but you do have that occasional neighbor that has a really nice house in your neighborhood or just down the block. And that usually happens. Most of the houses are the same. Occasionally you have some nicer houses than the rest of the neighborhood. So because of that, we would say that the mean is higher than the median because it's pulled towards that direction. So we'd say that the mean is $216,400 and the median is $172,600. It's like most houses. Usually it just takes one to throw it off. So we always want to describe what's going on here. Well, the distribution of houses or prices of houses tends to be skewed to the right. Okay, so I'm going to note this here. The distribution of home selling prices tend to be skewed to the right. So if it helps you, I'm just going to kind of draw a little picture, skewed to the right. Okay. Meaning a few high-priced homes in each neighborhood. This would pull the mean higher than the median. Okay. All right, number 3. Last one here. It says, last year a small accounting firm paid each of its 5 clerks $22,000, 2 junior accountants $50,000, and the firm's owner $270,000. What is the mean salary at this firm? Okay, so to get the mean, just to calculate this out by hand, is how I do it. 22,000, I had 5 people, plus 50,000 times 2 people, plus 270,000. Got to divide that by the 8 people, so this ended up giving me a mean of $60,000. The median, okay, is the middle. So if I think about this, 22, 22, 22, 22, 22, whoops, 50, 50, 270,000. I know these are in thousands, okay? The median's in the middle, okay? I have 8 employees right in here. There's my median, okay? So the median is equal to 22,000. So now, we got the mean, we got the median. It says, write a sentence to describe how an unethical recruiter could use statistics to mislead a prospective employee. Well, if they want to mislead them, they're going to use the mean, okay? Because if you look at this, the mean is higher than what 7 out of 8 employees make, okay? So because of that, okay, they definitely want to use the mean. Okay. So since, okay, 7 out of 8 employees make less than the mean, an unethical recruiter would report the mean salary as the typical salary, an average or average salary. When it is ends that CFU